Since the invention of lasers in 1960, lasers have found greater applications in our world. Today, lasers play a major role in various fields, starting from metal fabrication industries, military applications, medical applications, and so on. Lasers have dominated a lot. In this video, we will be learning about material processing using lasers. I'm your host Karthikeyan Jayakumar. Let's get into the video. Applications of lasers in material processing. What is material processing? Material processing dictates the resulting structures of a material, which in turn defines its properties and design. The operation of material processing involves a succession of industrial processes with various mechanical or chemical procedures, usually produced in large quantities or batches. Laser material processing. Laser material processing uses laser energy to modify the shape or appearance of a material. This method of material modification provides a number of advantages such as ability to quickly change the designs, produce products without the need for retooling, and improve the quality of finished products. Materials processing with lasers is now a firm element of manufacturing process in industry. Materials processing using a laser can be fast and precise. Types of material processing using lasers. The four main types of material processings are laser cutting, laser hardening, laser drilling, and laser welding. These are the most important material processing methods. First, we will talk about laser cutting. What is laser cutting? Editor, இந்த cutting இல்லப்பா.
குடியை கெடுக்கும் குடிப்பழக்கம் உடல்நலத்தை கெடுக்கும் குடியை கெடுக்கும் குடிப்பழக்கம் உடல்நலத்தை கெடுக்கும்.
Laser cutting. In this process, laser energy is focused into a very tiny spot by which the metal gets vaporized. When this is done, we get curves, that is cut, notch, groove, or cut face with narrow widths. Working of laser cutting. When the laser beam is used with a lens having focal length of 64 mm, that is 2.5 inches, the energy density can be as high as 10 power 8 watts per square inch. And this laser beam is focused on 0.127 mm to 0.254 mm in material, making the cut. This is the schematic diagram of a laser cutting arrangement assisted by a gas jet. It consists of a laser resonator which is used to produce a high energy laser beam. The energy output of laser needed for cutting varies from material to material. A beam bender, simply a mirror, is used to change the trajectory of the laser beam. A focusing lens of focal length 64 mm is used to focus the laser in a very tiny spot. The gas is always flown coaxially with the laser beam. These gases are known as laser gases. They help to achieve best quality of cutting. For example, in certain metals like aluminum and cast alloy X, a noble or inert gas is used as laser gas, but the cutting rate falls by 40%. Using oxygen in minimum speed increases the cutting rate. A plate of stainless steel of thickness of 0.13 cm can be cut at the rate of 0.8 meter per minute using a 190 watt CO2 laser using a jet of oxygen as the assisting gas. For cutting material like wood, glass, plastic, etc., which absorb most of the radiations, inert gases like nitrogen or argon can be used in the place of oxygen for laser cutting. A low energy 100 watt CO2 laser is used to cut papers and create various designs on it. Gas assisted laser cutting have exhausted their ability to keep up with the growing demand of quality. They cause thermal damage, contamination on the material. Instead of gas, the laser beam is guided by thinnest water jet. Thanks to the total internal reflection, this results in perfect cutting without any damage to the material. It not only offers exceptional precise cutting, it also ensures the material to stay cool and clean. Advantages of laser cutting. It cuts without touching the parts, hence there is no tool wear out and there will be minimum of part tie down. The cutting is at a very fast rate. The process can easily be adapted to computer control. With lasers, metal of thickness up to ½ inch can be cut. Laser hardening. Laser hardening is a process by which hardness of the material is increased by heating. During laser hardening, also known as surface layer hardening, the energy from the laser beam is applied directly to the component surface. The surface layer is heated up to hardening temperature, that is greater than 1000 degrees Celsius, in a reduced area within a short period of time. Commonly used lasers for hardening process is CO2 lasers. This is the schematic representation of a laser hardening technique. Advantages of laser hardening. Precise energy input with minimum heat effect. Low risk of cracking. Low distortion, so little to no finishing work required. Less hardness stress. No media required for quenching. The laser hardening process is suitable for nearly any steel of cast iron that contains carbon. The area under the laser beam instantaneously reaches the desired temperature. The laser beam is programmed to move across the surface of the workpiece. The effects of the laser hardening process can extend between 0.1 to 2 millimeters into the workpiece, depending on the material and the laser process parameters. Yo guys, thanks for watching this video. I hope you guys liked the video and find it informative. Please do like, comment and share it with your friends. It may be helpful for them also. For more similar content, please do subscribe to this channel. I'm your host Karthikeyan Jayakumar, signing off.